Let's talk about atomic weight. Some people confuse this with mass number because they both seem to do with weight or mass, but this is really a little bit different. This is a weighted average of all the naturally occurring isotopes. You see, the problem with coming up with a mass for a given element's atoms is that not all elements or not all atoms of, say, magnesium have the same mass. And that's because for magnesium there are 3 naturally occurring isotopes: magnesium 24, 25, and 26. And each one has a different mass because each one of these isotopes has a different number of neutrons. Do they have the same number of protons? They do, because they're all magnesium. Remember, the number of protons determines the element. Anyway, so they have each have a different mass in AMU, atomic mass units. And so we want to take some kind of average so that we can do calculations with the mass of magnesium atoms. The problem is, if we took these 3 numbers and did a regular average, where we add these 3 up and divide by 3, that wouldn't be so helpful, because this top one, magnesium 24, is the most common. In fact, most magnesium atoms are this magnesium 24. I could say 78.99% of magnesium atoms are magnesium 24. Anyway, so this one's mass should matter more when I take my average, and that's why we do what's called a weighted average. To get the weighted average, I take this is a fractional occurrence. Fractional occurrence is always 0 point something something. It's kind of like a percent, but it's off by 100, factor of 100. Take that, multiply it times each particular mass. So I'm going to write these down. I'm going to write extra digits on each one so that I'm only rounding one time at the very end. This is important on these problems to get them to work out. Then I'll do 0.1 times 24.986. So let me go up here and look at our significant figures. I have 4 in this occurrence, so this can only go to 4 digits. That will put it right here. It's the last digit to the right that's significant. The next one has 4 digits and 5, so 4. This is the last digit to the right that's significant. And this one again goes to here. So if I look at how these add up, how they line up, remember adding, we're going to add these 3 up is what we're getting ready to do. I want to add them according to the one that goes least far to the right. When I put all this in my calculator, I want to keep these extra digits and just round at the very end. And what I found is that I would get 24.31 for that, and that's AMU for my atomic weight. So that's an atomic weight. It's a weighted average of the isotopes that occur regularly in nature. Let's look in our periodic table for magnesium. Here's magnesium, and that number down there below it is the atomic weight. So the top number is our atomic number. The bottom number is our atomic weight. These numbers that I put on my periodic table are rounded off. So instead of 23.31, 24.31, it's just 24.3. But anyway, that's what the other main number on the periodic table is for. Let's try this example problem with chlorine's 2 isotopes. See if you can pause and get ahead of me and get it before I do. There's a difference here. This is a percent occurrence, and what we need is a fractional occurrence. And so I'll put that down here. How do I go from a percent to a fractional? Well, basically I'm dividing by 100. In other words, I'm moving the decimal place 2 places. I'm still multiplying by the mass of each known isotope. Write down extra digits on these problems. You'll find that's true on sapling, but you'll need those. I'm going to look at my significant figures. This top one should have 4, so it should round to that place. The bottom one should be there. Then I look at my numbers. When I go to add, I'm going to look at how far they go to the right. And this top one goes 2 past the decimal. This bottom one goes 3 past the decimal. So my answer can only go 2 past the decimal. So in other words, the atomic weight is 35.45 AMU.